Type how to become an AI engineer into YouTube, and you'll get 1,000 roadmaps. Almost every single one is selling you a course. So I did something different. I pulled the data on nearly 900 real AI engineer job postings from 26, and I cross checked it against the actual job descriptions companies are hiring on right now. And here is what I found: the roadmap everyone is teaching you is upside down. The flashy skills the influencers put first, retrieval, agents, prompt, engineering, those show up in barely 1 in 10 real job posts. The boring fundamentals everyone tells you to skip, they are in 70% of them. And the single rarest skill on the entire list, the one almost nobody teaches, is the exact thing that separates a $120,000 offer from a $300,000 one. This is the 2026 AI Engineer Roadmap, rebuilt from what actually gets people hired. First, where these numbers come from, because you should be skeptical. The hard percentages come from one rigorous analysis: 903 AI engineer postings, scraped from Glassdoor in April 2026 by the team at 365 Data Science. It is the only study I could find that actually discloses its sample size, its source, and its date. Most top skills articles just reprint these numbers without crediting them. So the agreement you see online is kind of an illusion. To make sure it held up, I read through real live job descriptions from companies like Bright AI, Mistral, and Zscaler. One honest caveat up front: that 900 posting set includes all kinds of AI roles, not just language model engineers. So it undercounts the newest tools. I will flag exactly where that matters. No hype, no inflated promises. Just the data and what it means for the order you should actually learn things in. So here is the actual demand ranking. Out of 900 real postings, the number one skill, by a mile, is Python. 71%. Not a framework, not a model, plain Python. After that, it is PyTorch at 38%, then a cloud platform, AWS or Azure, around a third each. TensorFlow, deep learning, then Java, of all things, at 22%. Kubernetes, SQL, Docker. Now watch where the exciting stuff lands. Fine tuning, 15%. Retrieval augmented generation, the famous RAG, under 14. LangChain, 11. AI agents, 10. Prompt engineering, under 9. And model evaluation, dead last, 5.5%. Look at that gap. The things that get a million views in a thumbnail are at the bottom. The fundamentals you keep being told to skip are at the top. Here is the honest nuance. That set mixes in computer vision and classical machine learning roles. So for pure language model jobs, RAG and agents sit much closer to baseline. But the lesson holds. If your Python and your cloud are not solid, no agent demo is going to save you. Which brings us to layer 1, the foundation that is in 70% of every posting, and that you cannot fake. Strong Python, not just notebooks, real, tested, readable code. One cloud platform. Pick AWS, it is the most requested. Docker and a little Kubernetes because real systems ship in containers. SQL because the data always lives in a database. And enough PyTorch to read a model and not be scared of it. This is the layer that is genuinely boring to film, which is exactly why no one makes videos about it, and exactly why so many self-taught engineers stall at the interview. Here is a real senior AI engineer posting. Look past the buzzwords at the top, and the requirements underneath are Python, cloud, containers, production systems. Build this base first. Everything above it is leverage. Without it, the leverage has nothing to pull against. Layer 2 is where you start touching language models. And the trick here is range, not loyalty. The real postings do not want someone who only knows one provider. They want someone who can move between Claude, GPT, and Gemini and pick the right one for the job. So learn the API patterns that are the same across all of them. Streaming, tool calling, structured outputs, where the model has to return clean JSON that matches a schema you defined. That last one matters more than people realize. Because in production, a prompt is not a clever sentence, it is a contract. It has to return the same shape every single time, or the code downstream breaks. Get comfortable making three different models obey the same contract, and you have already passed a bar most applicants fail. Layer 3 is the workhorse of the entire field, retrieval augmented generation, RAG. The idea is simple. Instead of hoping the model memorized your company's documents, you fetch the relevant pieces at question time and hand them to the model as context. A question comes in, you turn it into a vector, you search a vector database for the closest chunks, you stuff those into the prompt, and the model answers grounded in real data. Here is the part the tutorials skip. Building a RAG demo on a clean PDF takes an afternoon. Building a RAG that survives messy, contradictory, real-world data, ambiguous questions, and a document set that drifts over 18 months. That is the actual skill, and that is what gets paid. You will need a vector database, and you should know the trade-offs. Pinecone if you want zero operations and do not mind the bill. Qdrant or pgvector if you want it cheap, or you already run Postgres. VV8 if you want hybrid search built in. Learn two of them and learn why you would pick each. Layer 4, agents. And to understand agents, you have to understand the shift that happened underneath them. The old way was a chain. Step A, then B, then C. Run once, done. Useful, but rigid. An agent is different. It runs in a loop. It thinks. It takes an action. Like calling a tool or an API. It observes the result and then it decides whether to go again. Think, act, observe, repeat until the job is actually finished. That loop is why agents can handle messy, multi-step tasks a fixed chain never could. The framework that won 2026 for this is LangGraph, which models your agent as a graph with cycles and shared memory. Anthropic's Claude Agent SDK and Crew AI are right behind it. And Pydantic AI if you want type safety. You do not need all of them. Build one real agent that uses real tools and keeps state, and you will understand the whole category. Layer 5 is fine-tuning, and I want to be honest in a way most roadmaps are not. You probably need it less than you think. Only about 15% of postings ask for it, and a huge amount of what people try to solve with fine-tuning should have been solved with better retrieval first. But when you genuinely need to teach a model a specific style or a narrow task, here is the modern, affordable way to do it. You take a small, open base model. The right one in 2026 is Llama 318B. And yes, I am being specific, because there is no such thing as Llama 3138B, no matter how many roadmaps say it. You curate maybe 1,000 good example pairs, and you run LoRa or QLoRa, which fine-tunes a tiny fraction of the model cheaply, using Hugging Face's TRL library. Do that once, end-to-end, with a before and after evaluation, and you can speak about fine-tuning like someone who has actually done it, which leads to the skill that actually pays. Remember the demand ranking? The skill in dead last place, 5.5%, was model evaluation. Here is the counterintuitive truth. That is not a reason to skip it. That is the reason to master it. Think about what it means. Almost anyone can build a RAG demo that looks impressive in a screenshot. Almost nobody can prove the thing actually works, that it is not quietly making facts up. That gap between it demos well, and I can show you it is correct, is the line between a junior and a senior, and it can be worth $100,000 a year. The tool to learn is Ragas, which scores your system on real metrics. Faithfulness is the answer actually grounded in the retrieved text or hallucinated. Response relevancy. Does it answer the question? Context precision and context recall. Did you retrieve the right material in the first place? Wire that up with an observability tool like Langsmith or Langfuse so you can see every step. Be the person who can measure quality, not just produce it. That is the rare one. Now, none of this counts until it is visible. Datacamp's own hiring guidance says it plainly. Most AI engineers hired in 2026 have portfolios of shipped projects, not AI degrees. A recruiter spends under 2 minutes on your repo, and they reward something that runs, not a pile of notebooks. So build these six and deploy everyone. 1. A production RAG over genuinely messy data with citations and a real interface. 2. A tool using agent built in LangGraph and show the graph. 3. A fine-tuned small model with a before and after score. 4. And this is your secret weapon. An evaluation harness using RagSell on your own RAG. 5. A Dockerized cloud-hosted model API with logging and cost tracking. And 6. One app that runs across Claude, GPT, and a hosted model with typed outputs. 3 strong deployed projects beat 20 half-finished ones. Skip the Titanic classifier. Everyone has it. So what does this actually pay, and how long does it take? On the money, be careful. Because base salary and total compensation are very different in AI. At mainstream companies, entry level runs about 110 to 160,000 total. Mid level 170 to 260. Senior 220 to 350 and up. Staff and principal 350 to 600,000 and beyond. At the big labs, total comp for strong engineers runs higher still. And specializing in language models and RAG specifically adds a documented premium on top. On the timeline, here is the honest version. If you already write software, 2 to 3 months. Technical, but not a coder, 4 to 6. Complete beginner, 6 to 12 months, part-time. Anyone promising you a job in 4 weeks is selling you something. Now, do you need a paid course? No. But a structured one can save you months of wandering. DataCamp's Associate AI Engineer track, for instance, walks through this exact stack. Use a course as an accelerant, never as a permission slip. And one last thing about applying. The bullet points in a job post are a wish list, not a checklist. Apply before you tick every box. They never hired the person who waited until they felt ready. So let's flip the roadmap right side up. Master the boring foundation first: Python, cloud, and containers. Add the language model layers, APIs, then RAG, then agents in that order. Treat fine tuning as a sometimes tool and go deep on the one skill nobody else will: evaluation. Because that is the one that pays. Build 6 projects, deploy all of them, and apply early. If this gave you a clearer path than the 100 course ads you have scrolled past, do the 3 things that genuinely help this channel. Subscribe here on YouTube and follow us on Facebook and Instagram, where I post these breakdowns first. I went and pulled the data so you would not have to, and there is a lot more coming. I also turned this entire roadmap into a free 1-page PDF. The skill ranking, the 6 projects, the salary bands, and the exact learning order. To get it, comment the word hired on this video, and it will be sent straight to you, or grab it at the link in the description. And if you want the deeper step-by-step build guides, my paid guides are linked down there too. Now, go build layer 1. I'll see you in the next one.